Good morning, students. Happy New Year. Welcome to the class of Technomathematics. So today we'll be taking few questions. Okay, in the new year we are starting from today. So what are the questions? Let us see. We can just discuss in details. Okay. So the few questions which we can start for is just I selected this question which I found it useful is that a rectangular box is given to you. This is a rectangle. Inside this, considering this as a center, this semicircle is drawn. And considering this point as a circle, let us say if this is P and this is Q. Okay. So from P as a center, a semicircle is drawn, and from Q as a center, another semicircle is drawn. And that rectangle is A, B, C, D, right? Now we need to find the area of the shaded region. So we need to find the area of the shaded region. It's how much? Okay. So students, to solve such questions, we need to just see what are the figures that can be separated from the given one. Okay, I mean to say whether it's a square, circle, sector, segment, or any of the known two-dimensional geometrical figures which you are able to see. Though here we are able to see this is a semicircle and this is a reverse semicircle. Okay, but how to calculate this shaded area? It's definitely not coming into mind immediately. But it also given that the length of the side AB is 8 centimeter. Okay, this is given into the question, and the length of the side BC is 4, right? This data is given to you 4 cm and 8 cm. Okay, the length and breadth of the rectangle. So to find the area, do one thing, my dear friends. What we can do, just make a line, since this is the center and this is the center. Okay, so we can just draw a line like this. Okay, this line PQ will be parallel to AD and BC, right? And the length of this will also be equal to the same, what, 4 centimeter, because PQ equal to radius which is equal to 4 centimeter, that, or we can say the breadth of the rectangle, right? So this will be 4, so this will also be equal to 4, isn't it? And from here, let us connect it like this. Maybe this point is L, so PL will also be equal to 4, isn't it? Because this is the radius, because P is the center. Similarly, if this is, let us say, M, this point of intersection of the two semicircles, right? Then from P to M, this is also a radius, right? So all of this is equal to 4 centimeter. Now we need to find the area of the shaded region. So if we connect like this, similarly we can do from here, we can connect this Q to M. You can see Q to M, considering Q as a center, this is the radius. Similarly QP is the radius and QL is also a radius, right? If all these three are the radius and from P as a center, PL, PQ and PM are the radius, then we can say this PL equal to PM, which is equal to QM, which is equal to QL. Now to find the sector area, what we can see, that if this is 4, then definitely PL is 4, this one, and QL is 4. Isn't it a equilateral triangle? Isn't it a equilateral triangle? If this is an equilateral triangle, this angle will be equal to how much? We know the angle, each angle of an equilateral triangle is 60 degree. then we can say this is 60 degree, right? I mean to say this angle, right? Angle QPL is 60 degree. Similarly, this is 4 and PM is also equal to 4. So here also we can say this angle is also equal to the same, that is 60 degree, right? Now from P you can see PLQM is a sector, right? PLQM is a sector, sector of the semicircle with angle 60 plus 60, that is equal to 120 degree, right? So the area of this sector can be calculated very easily, right? How much? So this will be equal to complete. Let us find out the area of the complete circle first. Okay, complete sector. So area of the complete sector will be equal to theta by 360 into pi r square, isn't it? Theta by 360 into pi r square. So what is the value of theta? Theta is 120 degree. You can see 60 plus 60 is 120 degree. Hi Prince Gaming. Hello. Happy New Year my dear friend. Hello Satinder Pannu. So it will be 120 by 360 into pi r square. Pi r square will be, pi will be as it is, and r square will be the radius, which is equal to 4 into 4 square, right? So 120 will divide 360 in 3 times, and 4 16 by 3 pi. So it will be coming as equal to 16 by 3 pi centimeter square. This is the area. This is the area of the sector. Which sector? This area till this point. This one. This complete area is find out, but the area of these segments are still left. This one. Area of these segments. These two segments are left off, you can see. These two segments are left. So what are the area of these two segments? Segment area need to be calculated. Okay, so segment area can be seen if you find the area of this sector, if this PQM, this sector, and subtract the area of this equilateral triangle, then will not you get the area of this segment and area of this segment, right? So all, considering all these four segments are symmetrical, because all the radius of these both these semicircles are same, right? So we can say that yes, with this we can say that yes, area of the segment will be equal to area of this sector, which is a covering angle of 60 degree, right? So it will be theta by 360 into pi r square, radius is 4, right? Area of this sector, I'm just telling for this sector, right? This one, right? minus minus area of this rectangle, area of this triangle. Which triangle? Equilateral triangle, this triangle. So it will be equal to root 3 by 4 into side square, which is 4 square, right? Because this is an equilateral triangle, you can see this is an equilateral triangle, this one I am saying, this one, right? 4 4 4. So if this will be subtracted, you get the area of this segment, this one and this segment, two times this area will be found. So this will give you the two times the area of segment. So basically this is not only the segment, but into two you will get this area. And here also, this is one segment and this is also another segment, right? So this will give you the area of two segments, right? Will give you the area of two segments. And when you add it with the area of this sector, that is 16 by 3 into pi, right? You will get the, just add it, add this one and add this one, then you will get the total shaded area. Total shaded area, right? Did you got it? How we find? I think it's very easy. Let me explain it again. This is a semicircle, this is a semicircle, right? Two semicircles into the reverse direction to each other, right? So you can see for this semicircle, the breadth of the rectangle is 4, so obviously PQ, the radius of the semicircle will be 4. So that we have written it over here. This is PQ, this is the breadth. You can see this is the breadth, which is equal to 4. Now you can basically say this is not only breadth of the rectangle but also the radius of this semicircle AQB. If you see from this direction, right, this is a radius. Similarly, PL is the radius and PM is the radius. So to calculate the area of the sector PLQM, PLQM is what? This one, PLQM, the biggest sector, okay, with angle 60 plus 60, 120. And how this 120 degree came? Because this is the radius 4, which is equal to 4, and this is also the radius of the semicircle, and this is also the radius of the semicircle, right? So that's why we have written PL equal to PM, which is equal to 4, and this is making a bigger sector whose angle is 120 degree, right? So this sector having the area theta by 360 into pi r square, which is the standard formula of a sector, right? Apart from these, two segments are left, segment number 1 and segment number 2, right? So to calculate the segment area, you can see, if you consider just only this one, 50% of the area, here I am saying, if this area is considered, then from here you can see, if you subtract the area of this rectangle, equilateral triangle, right? Because this is also the radius, this is also the radius, this is the radius from for the circle which is having center Q, and PM is the radius for the same circle which is a center P, right? So in this way we can see that this is an equilateral triangle. Which one? This is an equilateral triangle, this one, right? PQM, we can write PQM as equilateral triangle. PQM is an equilateral triangle whose side is nothing but 4. This is 4, this is 4, this is 4, and this is also equal to 4. So if this equilateral area of if this area of equilateral triangle is subtracted from area of this sector, then you will get the area of this segment and this segment, isn't it? So 2 times the segment area is calculated when you consider this sector PQM, then that is theta by 360 into pi r square, whose one angle is 60 degree, this one, right, minus the area of the triangle. This will give you 2 times the area of this segment, right? You can see the same triangle is subtracted from PLQ sector. So these two segments, area of these two segments can be considered as area of these two segments, right? So this will be equal to area of the sector minus area of the triangle. So this will give you the area of 2 times the area of the segment, which will be added with the bigger sector area, to that is 16 by 3 into pi. So this will add up together to give you the total shaded area, my dear friend, right? In this way we have solved this question. Thank you, my dear friends. Thank you so much for watching and being connected. Bye bye. Take care.